Hey guys, today we're going to be talking about cryptography, one of the main things that is a fundamental part of today's IT security world. Let's start with a short overview of today's lesson. We're going to be talking about definition of cryptography, understanding what it is, and then going straight to history, short history of cryptography, in order to understand where it comes from, how it was created and invented, and who are the main people that stay behind it. Also, understanding what way today's modern cryptography is following and why is that. And we're going to be talking about symmetric and asymmetric cryptography, and at the end we're going to be looking into the final conclusion. So let's start with a short definition of cryptography. Cryptography is associated with a process of converting a plain text into unreadable, unintelligible text, and also the vice versa. So it is a method of storing and transferring data in a particular form so that only those people or machines, those users for whom it is intended, can read and actually process it. Cryptography not only protects data from different types of attacks, from data theft, alteration, etc., but can also be used for user authentication. Moving forward, let's look at the short history of that cool thing called cryptography. Cryptography is really a young science. Though it was being used for thousands of years in order to hide secret messages, systematic study of cryptology as a science, and perhaps some of you will see it as art, just started around 100 years ago. So you can imagine before 100 years people actually started to see this as science. Before that, it was just simple need for transferring confidential information over. So you might be hiding a specific message sent to the king, for example. It has to be understood and read only by the king himself. So you need a key. You send that weird combination of letters, symbols, whatever it is, over. No one during the transfer of that message is able to read it but the owner of the actual key. So with that key you're able to understand each letter and then decrypt the message, see it as plain text. So this was just a need, but 100 years ago, approximately about that time, people start seeing this as a science and has put more effort, more financial resource, people into it in order to make it more complex and actually include it almost everywhere in today's IT world. The first known evidence of the use of so-called cryptography, some form of it, was found in an inscription carved around 1900 BC in the main chamber of the tomb of the nobleman Kumhotep II in Egypt. So wow, you can imagine 1900 BC. The scribe used some unusual hieroglyphic symbols here and there in place of more ordinary ones. So today's archaeologists or scientists see this as a first type form of cryptology. Let's put it this way. The purpose was not to hide the message in this case, but perhaps to change its form in a way that it will make it appear dignified. Though the inscription was not a form of secret writing, but incorporated some type of transforming of original text, and actually this is the oldest known text to do so. There's some evidence of use of cryptography as seen in actually most major early civilizations. So you can say that those civilizations started to understand little by little the need of such thing as cryptography. Fast forward to around 100 BC, Caesar, we're talking about Julius Caesar, was known to use a form of encryption to convey secret messages to his army generals. You can imagine how important that was in order to maintain the secrecy of the tactics, warfare tactics, and basically win a specific battle or war, a whole war. So this was crucial here. We see it coming in the type of military world. This subscription cipher, known as Caesar cipher, is perhaps the most mentioned historic cipher. In all academic literature, you can see like a lot of times mentioning Caesar's cipher. So it was most likely, it has been mentioned in a lot of historical books or just old written scripts. So scientists has put it in a lot of effort to understand it and make it more popular to the public. So we mentioned the word cipher a lot. So in few words, we can say that cipher is an algorithm used for encryption or decryption. Pretty simple. It sounds simple, but in some cases it's really, really complex and sophisticated. You need a lot of manpower or just an automated machine to decrypt a cipher, decrypt a message using a specific decryption key. So those ciphers could be really complex. In a substitution cipher, each character of the plain text, and as I say plain text, I mean message which has not been encrypted at all, is substituted by another character to form the cipher text. So if you read it just like that, it won't make any sense to you. Ciphertext, as we mentioned, is the encrypted message. The option used by Caesar was a shift by 3 cipher. So each character was shifted by 3 places. Pretty smart and simple. So basically the character here, A was replaced by D, for example. B was replaced by E, and so on. So the characters would wrap around at the end. So X would be replaced by A. So this was the cipher that Caesar used. It's really easy to see that such ciphers depend on the secrecy of the system and not only on the specific encryption key. Once the system is well known, these encrypted messages can easily be decrypted, which poses a significant risk to the whole idea of such cipher. In fact, substitution ciphers can be broken by using the frequency of letters in the language. So those are not very strong these days. You shouldn't be using one of these because it will be easily to decrypt. During the 16th century, Vigenère designed a cipher that was supposedly the first known cipher which used an encryption key. In one of his ciphers, the encryption key was repeated multiple times, spanning the entire message. Then the cipher text was produced by adding the message character with the key character modulo 26. Modulo or mod is a mathematical expression which actually is used to calculate the remainder of division when one number is purely divided by another. As with the Caesar cipher, Vigenère's cipher was actually also pretty easily be broken. However, Vigenère's cipher brought the very idea of introducing such encryption keys into the whole picture. Though it was purely executed. Comparing this type of cipher to the Caesar cipher, the secrecy of message depends on the secrecy of the encryption key. So if the encryption key has been compromised, the whole secrecy of the entire communication using that encryption key will be compromised. Moving forward to the 19th century, everything became electric. Hubburn designed an electromechanical contraption which was called the Hubburn rotor machine. It used a single type of rotor in which the secret key was actually embedded in a purely rotating disk. The key encoded a real substitution table, and each key press from the keyboard resulted in a different output of cipher text. This was also rotated the disk by one notch, and a different table would then be used in order for the next plain text character. This was again broken by using letter frequencies. The Enigma Machine is something really popular, which was actually invented by German engineer Arthur Scherbius and used in World War I, heavily used of course, in order to encrypt secret messages to the different military groups, different leaders of countries that were actually involved into the war. And this Enigma machine was actually heavily used by the German forces during the Second World War. It was engineered and invented at the end of the first and heavily used in the second. This was really a huge advantage over the enemy. The Enigma machine used 3 or 4 or even more rotors. The rotor rotate at different rates as you type on the keyboard and output appropriate letters of ciphertext. In such case, the actual key was the starting setting, the initial setting of the rotor. The Enigma machine cipher was eventually broken by Poland, and the technology was later transferred to the British cryptographers, who managed to design means for obtaining the daily key, which brought huge advantage to the enemy of Germans. So again, it's really nice when you have a really innovative or strong encryption, but once broken, it could lead to a lot of trouble. So if really sensitive information has been decrypted by the wrong party, the wrong person, the wrong group, the wrong army, this could lead to a lot of losses and casualties in this case. It could cost the whole war, actually. So moving forward here, we can say that up to the Second World War, most of the work on the different cryptography algorithms, ciphers, and so on was used for military purposes. Usually, as we said before, used to hide secret military information, confidential stuff that were crucial to the warfare. However, cryptography started to attract commercial attention post-war, of course, with businesses trying to secure their data from different competitors. The use of cryptography became really a huge need for the business. In the early 1970s, IBM realized that their customers were demanding some form of encryption. So they started to form a crypto group headed by Horst Feistel. They designed a really innovative for those days, a really innovative cipher called Lucifer. In 1973, the National Bureau of Standards, this is called these days NIST, in the US, put out a request for proposals for a block cipher, which would become a national standard. So now we're actually looking into national standard for encryption. So this has to be really complex, really secure, tested beforehand. A huge number of people were involved in developing, testing, implementing such standard they had obviously realized that they were buying a lot of commercial products without any good crypto support. So that brought a lot of issues on the table. Lucifer was eventually accepted and was called DES. You've probably heard of the DES standard. That means Data Encryption Standard. In 1997, and in the following years, DES was broken by an exhaustive search attack. The main problem here for DES was the small size of encryption key. So here is the actual problem, and now NIST needed to come up with something new, something more advanced, in order to mitigate the vulnerability presented in this standard. As computing power increased, it became really easy to brute force all different combinations of the actual key to really obtain a possible plaintext message. That became a critical vulnerability, and in 1997 NIST put out a request for proposal for the creation of new block cipher. It received 50 submissions, and in 2000, it accepted Urgindale and christened it as AES, or actually the Advanced Encryption Standard. To conclude a little bit the whole history part of our presentation, we can say that the secrecy of your message should always depend on the secrecy of the actual encryption key and not on the secrecy of the encryption system. This is a principle known as Cherkov's. And the second important thing here is that, related to the previous one, is that always use cipher which have been publicly reviewed and have been established as standard. This is what history teaches us here.